picking up in lesson 3.5, we had already done A and B, and we had derived the formula for the derivative of the sine inverse and derivative of cosine inverse. So derivatives of inverse trig functions is what we're working with. And we were ready to talk about tangent. So given y equals tangent inverse x, find the derivative of tangent inverse x. So first thing we can do is we take tangent inverse out of inverse notation and write this as tangent of y equals x, right? And if you kind of check out the triangle that is pre-drawn for you, tangent of y, here's angle y, right? What's our saying for tangent? Tangent is what over what?
Sine.
In terms of opposite adjacent hypotenuse.
Oh, opposite over adjacent.
Yeah. Opposite over adjacent. So notice here, tangent of y is x, which x as a fraction is x over 1. So opposite is x, adjacent is 1. And of course, the hypotenuse would be found using Pythagorean theorem. Okay, so we're going to differentiate, right? We're going to do the derivative of tan y, and we're going to do the derivative of x. So,
Where did we get that from? Oh, the type equation.
yeah, just writing down that we're doing the derivative of both sides with respect to x. What is the derivative of tangent of something? Of tangent is secant squared, so this is going to be secant squared y times, what's the derivative of y? 1, but dy dx equals, what's the derivative of x? Just 1. So if we're going to solve this, dy dx is going to be 1 divided by secant squared of y, right? Now, which way do I want to go with this? I don't know. Which way do you guys want to go with this?
I don't know.
Okay, we can leave it as 1 over secant squared y, and then we can go here and figure out what is the secant of y, and fill that in. Or a secant in the denominator is what? A cosine in the top, right? So if you'd prefer, you could go this direction, say dy dx is cosine squared y. And now at least we won't have a fraction within a fraction that we have to deal with. So the cosine of y squared. Okay, what's cosine of y here? According to our triangle. Okay, 1 over square root of 1 plus x squared. And then that is squared, because it was cosine squared. What happens when we square that fraction? Well, 1 squared is 1. When you square the square root, we're going to get 1 plus x squared. So we end up with dy dx is 1 over 1 plus x squared. And that is the derivative of what? Tangent inverse. Okay? Those are the big three. The more you can be familiar with them, the better off you're going to be. Okay? I know the notes that I used previously with the Saxon book that Miss Byers had written always stated, make sure you know sine inverse and tangent inverse. Those are the two that, are most used. What I'm seeing here says sine, cosine, and tangent. Now, keep in mind, sine and cosine are just different by a negative sign, right? As I've been going through reviews and possible tests for this unit and everything, I've been using a lot of sine and tangent. I don't know that I've really used a whole lot of cosine. So, you know, be familiar with those. Okay, top of the next page. Here's your chart. Now, let me explain what we're looking at because they are a little bit difficult to understand. Is that a good way to put it?
Why does it say arc?
Okay, so I had to second guess myself. Have I taught this in calculus or pre-calc? Okay, I taught this in pre-calc. I went back and looked.
I was going to say sounds
Arc sine is another way to say sine inverse. And I went back and looked, and it is in our pre-calc books. So you did see that last year, I promise. Now, and as I said, I was second guessing, so I'm like, do I normally just teach that in calculus, or does it come up in pre-calc? And it does come up in pre-calc when we learn inverses. So the idea is arc, and I don't know exactly how I want to put this, but the idea is that if you see y equals sine inverse of x, that's the same as saying okay, it does not like me. Should have set this up differently. Okay, we'll go with that. Okay, so sine inverse is the same as arc sine x. That's just an equivalence you need to know. You never know what will be thrown in on you at AP. Okay? Okay. As we look at this, so the derivative of arc sine. So, of course, if you prefer, you can think the derivative of sine inverse, right? That's what it's really saying. Now, it says u prime over square root of 1 minus u squared. That u prime is just, that's indicating the chain rule part. So it's saying it's going to be the square root of 1 minus u squared, but then u prime says times the chain rule. So if we look at it with the view of, well, we automatically know the chain rule always applies, right? We apply it when we need to. If we look at it like that, then we could say the derivative of sine inverse x is 1 over the square root of 1 minus x squared. Okay? That u prime is just saying that you're going to do chain rule. Okay? And we'll practice that live. So I don't know if that helps me to show it to you like that, because I'll be honest, I like this basic notation a little bit better. But to be honest, I usually see the more complicated notation every time I look at stuff. So that means cosine inverse is negative 1 over square root of 1 minus x squared. And tangent inverse is 1 over 1 plus x squared. No square root there. Okay? So those are the simplified versions, if that helps. Yes, Megan?
Why are we writing dy dx? I feel like you told me this yesterday, but I forget.
Why am I not writing dy dx?
Where's the y?
When you put d dx in front of something, if we were saying dy dx equals, that's when we usually use dy dx. d dx is just saying taking the derivative of this function with respect to x. Okay, and it's just...
So d dx sine inverse x equals dy dx.
I guess you could say that, yeah. Because your sine inverse would be your y value there.
You said that again?
So d dx of sine inverse x equals dy dx.
Which is the derivative of y with respect to x. I could go with that. There's a lot of notation in AP, isn't there? So, I know, it's trying to get it all straightened out. Same thing for me sometimes. Okay, we haven't really worked with cosecant, secant, and cotangent. And to be honest, I'm trying to think if they even come up in homework. I'm not sure I really saw much of them, but realize cotangent is just going to be the negative of the tangent. So it's negative 1 over 1 plus x squared is your derivative there. Secant, again, just think about these as ones, right? Secant is 1 over the absolute value of x times the square root of x squared minus 1. Cosecant is just the negative of that. Negative 1 of absolute value of x, square root of x squared minus 1. Okay? Okay. Shall we try some examples? It's using the rule, and then we've got to remember chain rule, of course, right? So, if y equals sine inverse of 5x. Here you go, guys. Y prime. Or I could write dy dx there, right? Okay. So essentially, right there, we're taking the derivative of y, but with respect to x. So that's why we can't just say the derivative of y is 1, it's dy dx. Okay? Derivative of sine inverse of something. So what's derivative of sine inverse look like? 1 over square root of 1 minus x squared. What do I mean x squared? What is your x here? 5x. So when we do the derivative of sine inverse, it's 1 over the square root of 1 minus our inside squared, right? So this time our inside was 5x, so we're squaring 5x. Am I done? No, because there's a chain rule, right? So we already did the derivative of sine inverse. The insides is 5x. What's the derivative of 5x? 5. Okay. Now, professionals will have already put that 5 in the numerator. That's what you'll see the answer key happen sometimes, right? I don't know, maybe I should use the word professionals, but that's what I feel like it is. Other than that, we can do a little cleanup. So that 5 is a whole number 5. It can go on top. In the square root, 1 minus, what is 5x quantity squared? 25x squared. If I had to guess, that is where we would leave our answer. Are you guys okay with that? Because I'll be honest, when you look at how the answer key is, they use a lot of U substitution. And we haven't really gone into U substitution. We haven't really needed it. But just to kind of, like, this is it. We're done. This is our answer. Okay? Yes? Because when it says to do 1 minus x squared, or u squared, you're taking whatever is in right here. That right there, and you're squaring it. Okay? Now, the idea, and I'm just going to mention it. It might be helpful, but, well, I don't even know if I want to mention it. Nope, you know what? We're just going to go with it as is. You guys seem comfortable with that? I'm just going to go with it. So, the answer key may be a little iffy in places because there's a lot of U substitution used. We'll have to see. Okay, let's try B. Tangent inverse of the square root of 2x plus 1. So, what is the function we're trying to take the derivative of here? Tangent inverse, right? So, what's the derivative of tangent inverse of something? The derivative of tangent inverse of something? 1 over 1 plus something squared. Is that a good way to put it? So 1 over 1 plus, and it says x squared, but what is in our x place? Square root of 2x plus 1 squared.
Perfect.
What?
Oh, I was just, because we're squaring at the square root. So.
Yeah, that'll make it nice in the denominator, right? Times what?
Oh, you need to do the.
So now we're doing the derivative of the square root of 2x plus 1. How do we do the derivative of a square root? 1/2 times what's under the square root, 2x plus 1, to the negative 1/2. So that's how we do the derivative of the square root. Then what's under the square root? 2x plus 1, the derivative of 2x plus 1 is 2. Are we okay with those pieces? Okay. Now, as we clean this up, what do you know about 1/2 times 2? Those are going to end up canceling each other out, right? Now, let's see. This is going to take a step or two. 1 over 1 plus, what about the square root of 2x plus 1 squared?
Just 2.
2x plus 1, right? Times over here, my 2's canceled. What about 2x plus 1 to the negative 1/2?
1
It's 1 over
square root of 2.
square root of 2x plus 1. Okay? Clean it up. First of all, this can all become one fraction, right? On top, 1 times 1 is 1. In the denominator, 1 plus 2x plus 1 is
2 plus 2x.
2x plus 2. Put that in parentheses, please. Because that whole 2x plus 2 is getting multiplied by what? Square root of 2x plus 1. This would be a final answer. Or an equivalent final answer would be to factor out GCF of 2 there. Right? You don't like that?
Unnecessary.
And here's my deal. I'm fine with not doing it and saying it's unnecessary because I know you guys can see 2x plus 2 and be like, oh, that's 2 times x plus 1 as well. Like, I have pure confidence if you get that, your first answer on a test, on a multiple choice test, and you see this, that you would connect that. Okay? Yes, you would connect it. Okay. Ready to try the next one? Okay, we're going to keep plugging along.
I think this is kind of relaxing.
Relaxing? Okay,
Well, until it gets hard.
honestly, that last one was difficult if you ask me. I mean, yeah, we're going to probably hit some more difficult ones, but that last one was pretty difficult. Okay, y equals arc cosine x squared. So what is this really if you don't like that arc cosine? That is cosine inverse of x squared, if you would prefer, if your brain works better that way. Gosh, that negative 1 got out of the end there.
A brush?
Yes.
You know, you've been able to get a chance, you'll think about it.
It will depend if I have time at the end of those. If I have time, I'll do it right at the end of class. When we get done with notes, we need to register for AP. He came yesterday afternoon and wants it done before fall break if possible. I said, I'm not here on Friday though. And he goes, well, or right after break. I said, okay, if we don't get to it tomorrow, being today, guess what we're doing Monday?
AP.
I wondered when we would.
I got it right. I've got my reminder out right here. Okay. Now, ready, guys? What is the derivative of cosine inverse of something? Okay, negative 1 over square root of 1 minus something squared. What is something here? X squared. So it's under that square root, it's 1 minus x squared, squared if you will. Or you can go ahead and write it out as x to the fourth. I don't care, that'll be my next step. Times the derivative of
X squared.
x squared.
2x.
2x. Okay, this cleanup's pretty good, pretty easy. Got it? Move the 2x to the top. Negative 1 times 2x is negative 2x over square root of 1 minus x to the fourth.
So you multiply them or add them?
The exponents,
Yeah.
you are multiplying. It's a power raised to a power. The difference of, let me use a different number. X squared to the third is x to the sixth, as opposed to x squared times x to the third. That is, yes. Does that sound familiar? Good old Algebra 1 review there. In this case, you got lucky in that your 2's were 4 either way. Okay. Sine inverse. Derivative of sine inverse of something.
1 over square root 1 minus x to the square minus 1 squared.
Okay. 1 over square root of 1 minus something squared. My something is x squared minus 1. So you'll notice I put that binomial in parentheses, didn't I? Okay.
Times 2.
Times the derivative of something, the derivative of x squared minus 1, 2x. And if you prefer to go ahead and put that 2x in the numerator, that's fine. You are quite welcome to do that. I am so not against that. Usually we have to clean up the denominator yet, so. But if you're recognizing, oh, my answer is going to be done right here, you could go ahead and do that. Let's see. We know there's a 2x on top, right? Did I clean up that denominator some, or did I leave it? Kind of guessing I cleaned it up. Ah, I did clean it up. So, and there's a reason why, and it's something I want to make sure and address here. So, 1 minus x squared minus 1 squared, we know we need to distribute, FOIL, right? And we're going to be subtracting this. So x squared times x squared is x to the fourth, but I'm subtracting, so it's minus x to the fourth. Minus 1 times x squared and minus 1 times x squared is minus 2x squared, but I'm subtracting, so I'm going to say plus 2x squared. Are you tracking with me here? And then when you FOIL minus 1 times minus 1, it's plus 1, but I'm subtracting, so I'm minusing 1. So I FOILed and applied the minus sign all at the same time, if you guys are okay with that. Under the radical, this cleans up to be negative x to the fourth plus 2x squared. Okay, I need to address something here because I saw it happen some in homework, and I want you to be aware of it, something you need to be familiar with. In that radical, what do you notice?
X squared.
GCF of x squared, right? Okay, so let me take a couple steps to get you where I'm going. So underneath that radical, I'm going to factor out x squared, right? X squared times, then it's going to be negative x squared plus 2, yes? Okay, 2x is still good on top. In that denominator, okay, obviously negative x squared plus 2, I can't take the square root of that, right? Can I take the square root of x squared? And what is the square root of x squared? X. But since it's coming out from under a radical, what kind of value must x have?
Plus or minus.
It can't be plus or minus. It has to be positive. So when we take a square root in an equation setting, that's when we say plus or minus. A radical, in other words, this official symbol, when you run into a radical within a problem, it indicates that whatever is, when you take that square root, it is a positive value. So we need x to be a positive value. So when we take the square root of x squared and say it's x, we have to say absolute value of x times the square root of negative x squared plus 2.
So if we're finding the square root of something, it has to be plus or minus, but it's already there.
Yeah, basically, if you're in an equation setting, the radical is not already in the problem when you take the square root of both sides, right? You are adding in that radical. When you're adding in that radical, and like one of your operations is to take the square root of both sides, that's when we say plus or minus. The official radical itself, like this radical was part of the problem, indicates we just want the positive value. If they wanted a negative value, it would say negative of the radical. Okay?
Those x's cancel.
They do not? That's a really good question. They do not, and it's because of the absolute value of x there. I was trying to process if you did cancel and how you work the signs there. And that's where it's a little, that's why you can't cancel it, because if you put in a positive value for x, sure, you can cancel the x's. If we put in a negative value for x, well, this x is negative, but then this x would still become positive. So that's why we can't cancel. Okay? Okay, so be aware of that. Okay? I want to make sure I pointed that skill out. Okay. Y equals tangent inverse of cosine x. What is the derivative of tangent inverse of something? One over 1 plus something squared. Something being cosine. Okay, so 1 over 1 plus cosine squared times the derivative of cosine x is negative sine x. Now, this would be a good one if you had just wanted to go ahead and write your final answer, because all I'm going to do on this next step is put it together as one fraction. There's not going to be any simplifying I can do. 1 times negative sine x is just going to be negative sine x over 1 plus cosine squared x.
Like that.
Yes?
You can't, okay, this might be stupid. You can't make the 1 plus cosine squared x in the sine squared.
Isn't it? Because it's not one. It's 1 minus, not 1 plus.
The Pythagorean identity is sine squared plus cosine squared equals 1. So as much as we want to, trust me, I thought the same thing when I first did these problems. 1 plus cosine squared is nothing. Now, if that said 1 minus sine squared, I'd be all for it. And you'd be expected to. Not even just like, oh, sure, let's do that. No, it would be expected. Okay? Yep. Okay. F. Derivative of sine inverse of something. Okay, you guys got it? 1 over square root of 1 minus e to the x squared times e to the x. Okay? Cleanup. E to the x, of course, can go on top. Under the square root, 1 minus, okay guys, you need to be aware, what is e to the x quantity squared?
E to the 2x.
E to the 2x, right? Because just like over here, it's a power raised to a power, and x times 2 is 2x. You're not going to see something left as e to the x quantity squared. You're going to see it go as e to the 2x. Are we getting a good algebra review today while we're at it? Okay. Ready? Example 3. Surprise, surprise here. Find an equation of the tangent line to the graph of the function y equals arctan x over 2 at the point 2 comma pi over 4. Okay, so shocked, right? I don't need to really teach this, right? you know what to do. We're going to start finding the derivative. What is the derivative of tangent inverse of something? Okay. 1 over 1 plus something squared, which is x over 2, quantity squared, times, what's the derivative of x over 2? What's the derivative of, can we agree that x over 2 is equivalent to 1/2 x? So what's the derivative of 1/2 x? 1/2. So the derivative of x over 2 is 1/2. Does that work for you? Okay. I saw that technique come up several times, and I don't know if I was working on homework or test review at this point, but that kept coming up. Now, I would encourage you, I mean, technically we're just going to plug values in, so I guess you could leave it like this, but I feel like we should practice cleanup here, because there's definitely some cleanup that can happen. If we make this one fraction, 1 times 1 on top is 1. On bottom, there's going to be a 2 times this, right? So I'm just going to put 2 out front times what's in parentheses, which is 1 plus, what is x over 2 when I square it? X squared over 4. Okay, so there I've made it into one fraction, yes. We're not going to leave fractions within fractions. That's what we need to discuss here. Now, first of all, my opinion is I would go ahead and distribute the 2 so I know what's happening there, because that will slightly help. If we distribute the 2, 2 times 1 is 2 plus, what happens when you do 2 times x squared over 4? It's 2x squared over 4, but 2/4 can reduce to 1/2. So it's x squared over 2. Okay, guys, what do I do so I don't have fractions within fractions here? Multiply by what? What's the denominator I want to get rid of? A 2. So we're going to multiply numerator of the whole fraction by 2 and denominator of the whole fraction by 2. So 2 times 1 is 2. On bottom, you're distributing this 2, right? 2 times 2 is 4 plus, what's x squared over 2? X squared. Not that you had to have this cleaned up form here, because we could have plugged into that nasty beginning form. However, that looks much better, and that's the form you would see like in a multiple choice, what's the derivative of this?
We can't make it 1/2 because they're
Correct. I mean, if you're going to do 1/2, you're then at 1/2 plus 2 over x squared. I like what I have. Personal opinion. Okay? Not that you couldn't if you needed to. Okay, what were we doing? Equation of the tangent line at the point 2, comma, pi over 4. So, we need to find the slope, which means I'm going to take dy dx, or y prime, and I'm going to evaluate it at the point 2, comma, pi over 4, which is really just the 2, isn't it? 2 over 4 plus 2 squared. Which is 2 over 8, which is 1/4, if I've done my math correctly. Slope is 1/4. Point was provided as 2, comma, pi over 4. Write your equation. Y equals 1/4 times x minus 2 plus pi over 4. Okay, example 4 when you're ready. Okay. Example 4 when I'm ready, I guess. I was reviewing what I did there. Find the derivative when tangent of 4x minus y equals 4x. Now, we could use implicit differentiation in terms of the derivative of tangent of something. Keep in mind, that's not tangent inverse right now, is it? Derivative of tangent of something is secant squared of something. We could do implicit differentiation. Okay? I can't say that I worked it out, so I can't, say how ugly it gets. It's probably not pretty. This problem in general isn't pretty, though. But keep in mind, we're working with inverse trig functions today, yes? And any equation, as long as you are consistent and what you do to one side, you do to the other side, we can do that, right? And so what we're actually going to do is we're going to take and the hint here, the trig functions will all disappear. Okay, well, what will undo a tangent? And what will undo a tangent is tangent inverse. Now, if we apply a tangent inverse to the left, we have to apply a tangent inverse to the right. So what we're going to do here is on the left, we're going to take the tangent inverse of tangent of 4x minus y. So basically, I just put a tangent inverse in front of the left. And if I did that on the left, we're going to do it on the right. So on the right, it's going to be the tangent inverse of 4x. Now, tangent inverse of tangent. What do you think those guys do to each other? They cancel, right? They undo each other. So if you take the tangent inverse of the tangent, they're going to undo each other, and I'm just left with the insides, which is 4x minus y. So 4x minus y equals tangent inverse of 4x. Now, again, here you can implicit differentiation right here. But this equation is also very easy to solve for y, isn't it? So I would go ahead and make it y equals, which let's see how you feel about this. Can you agree that y equals 4x minus tangent inverse of 4x? Catch up with the math. And if you don't like it, write it down in 2 steps, right? If you're looking at me saying, nope, don't like it, that's fine. You don't have to like it. But basically in my brain, I add y to the right. That makes it positive y. 4x is already over here. I subtract tangent inverse 4x. But then I also, at the same point, flip-flop sides. Okay, can we differentiate now? Okay, derivative of y, dy dx. Derivative of 4x, 4. Minus derivative of tangent inverse of something, 1 over 1 plus something squared times the derivative of something. And that's going to be the derivative of 4x is 4. I went ahead and put the times 4 in the numerator. Times 4 beside the fraction is fine. Because we're going to have, let's see, we're just finding the derivative here, aren't we? Okay. So, we're going to do a little bit of cleanup here. Because again, is this the answer you would see on an AP test? No. So, it's going to be 4 minus, then as a fraction, 1 times 4 is 4, over 1 plus 4x squared is 16x squared. Now, how do you make these into one fraction? Common denominator? What is my common denominator? 1 plus 16x squared. Now, do you guys know how to do like the kind of like a cross product shortcut? Do you guys do that at all? Where basically this numerator times this denominator, 4 times 1 plus 16x squared, minus this numerator times this invisible denominator over here, which is 1, minus the two denominators multiplied, or divided by the two denominators multiplied. Or is that not making sense? It's kind of a shortcut.
Cross multiply and divide? Is that-
Kind of?
I don't know how to do that.
Yeah, I don't know. Okay, regardless. Basically, this 4 has to multiply by 1 plus 16x squared, right? So when I do 4 times 1 plus 16x squared, 4 plus 64x squared, minus the 4 from the second fraction, all over 1 plus 16x squared. Fours obviously cancel on top. 64x squared over 1 plus 16x squared. And yay, we met our final answer. I met my answer in my notes here. What am I doing? Okay, moving along, 2 more, right? Let g be the inverse of the function f on the interval 0 to pi. Find the value of g prime of 1. What are we doing here? Derivative of the inverse, right? Because what is g? G is the inverse of the function. So basically right here, they're saying g is f inverse. So when they're asking you to find the value of g prime of 1, they're asking you to find, yikes, derivative of f inverse of 1. That's what your brain has to connect here. So we need to use our inverse formula from the last lesson. That was last lesson, right? Yeah. Lesson 3.4.
You good?
Just call.
I took on water.
So we're trying to find g prime of 1, which is 1 over. We normally say f prime of f inverse, right? It's f prime of f inverse, except we're not supposed to be using f inverse, we're using g. Of what value? 1. I don't know why that looks so weird, but it does. There we go. It is. Okay. G of 1. Okay, so this is where my brain says if I need to find g of 1, then I'm looking for f of what equals 1, right? Because g and f are inverses. So if I need to find g of 1, I need f of what is 1. And so in this case, what's f? 2 cosine x. So when does 2 cosine x equal 1? Right? Because that's my f function. So when does 2 cosine x equals 1? Really, it's when does cosine x equal 1/2? When does cosine equal 1/2? The one at the bottom of the chart. Huh? Yeah, which if you think, my brain, first of all, and I'll be honest, my brain will sometimes go 30, 45, 60. But then I have to convert, okay, 60 is pi over 3. And we just want pi over 3 because it's just 0 to pi. If we go over into quadrant 2, cosine is negative there. So we want x is pi over 3. So that means right here, f of pi over 3 is equal to 1, so g of 1 is pi over 3. So right over here, g of 1 is pi over 3. So now I need 1 divided by the derivative evaluated at pi over 3. Okay? What is the derivative of 2 cosine x? The 2 just stays. The derivative of cosine x is negative sine x. And so then we want to know the derivative evaluated at pi over 3. So negative 2 times sine of pi over 3. Well, sine of pi over 3, it's not 1/2, it's the other one, which is square root of 3 over 2. So we got negative 2 times square root of 3 over 2, which is just going to be negative square root of 3. So take that back and fill it in. G prime of 1 is 1 over negative square root of 3. We can. I mean, I feel like it's hit and miss in the answer key. Sometimes it's left like this, sometimes it's rationalized. Could you still rationalize it if you had to? You would multiply by square root of 3 over square root of 3. You'd have square root of 3 on top. We'd have 3 on bottom, so it'd be negative square root of 3 over 3, right? You know. Okay, last one, I believe. Find the slope-intercept form of the tangent line at pi over 4, comma negative 1 to the graph of that. Round to 3 decimal places. Round to 3 decimal places gives you an indication of what? You're going to have to use a calculator at some point. Now, it would be great if this was explicitly solved and this was y equals, because we could do the whole thing in the calculator then. However, we've got to derive. This is kind of uglyish. We're going to implicit differentiation, yes? So, derivative of x squared is 2x plus, note a product rule here. The derivative of x is 1 times tangent inverse y plus, now I'm going to keep the x and multiply by the derivative of tangent inverse y. One over 1 plus y squared. Since we just did the derivative of a y thing, though, we're going to now say times dy dx equals the derivative of y on the other side. Dy dx minus the derivative of 1 is 0. Okay, dy dx terms on one side, everybody else on the other side, yes? Now, did I do that? And I did, okay. If I keep this dy dx right here, and I move this over here, yes? I'm going to have dy dx is over there. When I factor out that dy dx, realize this first is going to still have a 1 representing it, right? Minus this fraction. Because that's what I'm getting ready to write out. So, I'm going to go ahead and factor out my dy dx. The 1 that's already there minus the 1 over 1 plus y squared. Oh. Okay, so where should that x be? In the top. Yes, thank you. I was getting ready to totally lose that. Which, oh, that would have been a pain. Thank you. Yep, there should be an x there. I forgot about it. Maybe a reason I should have just put the x on the top to begin with. Because I was going to lose it. Okay, equals. What still stayed over on the other side? 2x plus tangent inverse y. Okay. Keep in mind we're going to plug this into the calculator, yes? I started to clean this up, but then when I checked it against the notes, they left an ugly form because what are we doing? Plugging into the calculator. So if you look in the notes, it's dy dx is 2x plus tan inverse of y divided by 1 minus x over 1 plus y squared. They didn't clean it up past that because we're going to put it in the calculator. And then what do you have to do? Take that and evaluate it at pi over 4 negative 1. I'm going to write down the value that I have because we are running out of time. $1.2932609293 is what you would get once you plugged all that loveliness into the calculator.
How do you do multiple variables?
Because x is going to go in every place you have an x. Y is going to go in for the y's,
Oh.
right? Okay, officially it was slope-intercept form of the tangent line, right? So y equals the slope, which is at 1.293 times x minus pi over 4 minus 1. If you clean that up, and I'm not saying you, I guess it did say slope-intercept form. It's 1.293 x minus 2.016. Okay, that would be some calculator work, right? Okay, so we will not be registering for AP Classroom. I guess I could always tell Mr. Hallenstein he could come in and register you guys tomorrow. I mean, you do have a sub tomorrow, but I am perfectly fine with doing it Monday after we get back. I guess if he really wants it done, I'll say, have at it. You guys will be here with the sub. Okay, so remember, I am gone tomorrow.